Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Mr. I one of group members from Group 4. Today, my group will talk about the production of isopropanol from indirect hydration. Okay, this is a list name for our group. The first one we have is Nur Shamira Natasha binti Rizwan. Second, we have Nur Adani Afni binti Khalid. The third one is me, Muhammad Zafifi Mu'aji. The last one is Muhammad Zaid Daniel and Muhammad Helmi.
Salam and hi, my name is Mira and I will be explaining and defining the isopropanol, the methods to produce isopropanol and the kind of method that is used in this project. Proceed to defining isopropanol. Isopropanol, also known as isopropyl alcohol or 2-propanol IPA, can be referred to as a flammable and colorless chemical compound with a strong distinctive smell. The IUPAC name. There are several methods of producing isopropanol introduced by the scientists until now. Back in the days, the indirect hydration process was the only method until direct hydration process was introduced in 1951. Direct hydration process is overall better than indirect hydration, as it only requires a single-step reaction using solid or unsupported acidic catalyst, while indirect hydration requires the use of sulfuric acid with 2 steps of reaction. One other method to produce isopropanol is by the process of catalytic hydrogenation of acetone. It applies the reduction process of acetone via catalytic hydrogenation, which would then generate isopropyl alcohol. In this project, the method that is used to produce propanol is indirect hydration of propylene.
Salam and hi, my name is Muhammad Zarin bin Muhammad Helmi, and I will explain to you about our block flow diagram. The first one is our input, which is Rg propylene, will flow into the input stream to the absorber reactor. Then the output for absorber reactor will flow to the stripper reactor. From the stripper reactor, there is 2 output, which is one will go to the acid reconcentration and go back to the absorber reactor, and the other one will flow to the caustic scrubber output flow with addition of caustic solution. And the stream that go to caustic scrubber will added with caustic solution, and the output is going to propylene column, and we will get the output of propane. The other stream will go to crude isopropanol tank, and the output of crude isopropanol tank will go to ether separation, and the output for ether separation is R2, and the first one will go back to the absorber reactor, and the main output will flow to the alcohol column. From the alcohol column, there is 2 output, which is wastewater, and the final one will go to the drying part, which will result in 2 output, which is wastewater and the desired output, which is isopropanol.
Salam and hi, my name is Nur Adianis Afni and I will proceed to process description. The indirect hydration process to produce isopropanol involves 2 main reactions. Firstly, propylene react with sulfuric acid to produce isopropyl hydrogen sulfate. The chemical equation we can see on the slide. The isopropyl hydrogen sulfate then react with water in a hydrolysis reaction to produce isopropanol and sulfuric acid. Also, you can see the chemical equation on the slide. Indirect hydrolysis for isopropyl alcohol production is a bit more complex than direct hydrolysis. Okay, for first process at the absorbent reactor. The first step in the production of isopropanol involves reacting propylene with sulfuric acid in an absorbent reactor to produce isopropylene sulfate. The reaction takes place at a high temperature and pressure and it catalyzed by a small amount of sulfuric acid. The reaction produces a mixture of isopropylene sulfate and a reacted propylene. Next, we can see at the figure, the isopropylene sulfate is then sent to a stripper reactor when it heat and decomposed to isopropanol and sulfuric acid. The reaction is isothermic and produce a significant amount of heat, which is removed by a cooling jacket surrounding the reactor. The sulfuric acid is then separated from the isopropanol by distillation and sent back to the absorbent reactor for reuse. And acid reconcentration. The sulfuric acid that is separate from the isopropanol in the stripper reactor is sent to an acid reconcentration unit, where is it reconcentrated and reused in the absorber reactor. This is done to minimize waste and reduce the amount of sulfuric acid needed for the process. The next step, caustic scrubber. The isopropanol is then sent to a caustic scrubber to remove any remaining sulfuric acid. In this unit, the isopropanol is mixed with a caustic solution which neutralizes any remaining sulfuric acid and remove it from the isopropanol. The sulfuric acid is then sent to the acid reconcentration unit for use. For the next, I will pass to Zarif.
Okay, in this part, I will explain to you about the propylene column. Okay, the function of this propylene column is to separate the unreacted propylene from the isopropanol. The isopropanol will send to the top of the column and the unreacted propylene will send to the bottom. The unreacted propylene will recycle back to the absorber reactor for use. The next equipment is crude isopropanol tank. The isopropanol will store in a crude isopropanol tank, and this tank is used to store the isopropanol before it sent to the next stage of the process. So next is ether separation. The isopropanol will send to ether separation where the isopropanol will mix with ether to remove any remaining water. And the mixture will send to a separator which ether and water will separate it from isopropanol. The next part is alcohol column. In this part, isopropanol will purified further, and the last part is drying, which is the purified isopropanol will send to this equipment or this part of process to remove any remaining water or excess water. Okay, both of this is the last part of equipment that being used in this process. The first one is steam boiler, which is this equipment used to generate steam that will heat the reactors and other equipment. And the second one is cooling tower, which is the function of cooling tower is cool the water that being used in this process before it reused again.
Assalamualaikum and hi. My name is Muhammad Isopropanol. So I will continue with the conclusion. The production of isopropyl alcohol or isopropanol is aided by developing a 2D drawing of the process flow diagram using the AutoCAD software. It is proven beneficial in providing a visual representation of the process and all of its components. This can help engineers and operators understand the flow process better and identify the potential issue or improvement. It is good in making sure the production can be run smooth as it has many advantages such as reducing the error and chance of mistakes. It can also save time and money because AutoCAD works speedily with user-friendly interface and workflow, showing its efficiency as many technology as provide in the software. Additionally, 2D drawing can be easily shared and modified. Therefore, it is useful for engineering that all parties involved have a clear understanding of how it works. They can be used to identify the potential safety hazard, optimize process efficiency, and troubleshoot issue. Furthermore, 2D PFDs can be used as a reference for the future modification. That's all. Thank you.